mentioned a moment ago, we're going to focus on what's going on underneath the radical today instead of the whole equation. And that's in this thing called the discriminant. So we're still on page 3 of the notes. We're just towards the bottom. We still got extras in the back if we need them. So just like yesterday, we need to make sure that we're equal 0 to begin with, so our A, our B, and our C value are right. But the discriminant is only that little piece that was under the radical. So notice, no radical today. Just this b squared minus 4ac thing. So there's a couple of ways that I can do this. One's with a graph and one is algebra-wise. And the discriminant is going to tell us how many answers there are to something. It's not going to tell us what the answers are. We need the quadratic formula for that. But it will tell us what we can have rolling here. So for instance, I'm going to actually put some real answers to these, but we're just going to draw some quick sketches in here at the start, and then I'll show you some live examples that'll make it a little easier to see. So if, when you plug in your b squared minus 4ac, you get an answer that's greater than 0. In other words, you get a positive number as an answer. What's going to happen on your graph is something like this, where it's going to cross the x-axis in 2 places. There's going to be 2 answers. So just kind of thinking visually, and I'll show you an example of this in a second here when we do a little calculating. That's what it's going to look like. Actually, let's do that. So let's just say, for instance, I give you, okay, the equation 5x to the second power minus 12x minus 3 equals 0. We're going to plug those in to this discriminant formula. So, just like it was, try that again. Just like it was with the quadratic formula yesterday, A is the number in front of x squared, B is the number in front of x, C is the number hanging out on its own. So if I plug that into this formula, so I've got b squared minus 4 times a times, oh, I smashed that a little more than I wanted. And I got to type it in exactly like this, parentheses and all. And I get out a positive answer. It just means there's going to be 2 solutions. So like if I was to go into y equals and type the equation in, we'll see if this is going to fit. If not, I got a way to make it fit. So you notice it crosses the x-axis in 2 places. Those are the 2 real solutions that we're talking about. So the same expression, I can look at it on a picture to see how many real solutions there are, or I can let this little formula tell me. They both work. And so as we do this through the rest of these, the formula stays the same. Yeah. And so if I take some numbers and I plug them in and I get 0, I'm going to have 1 real solution. So like, for instance, let me make up another one here as we go. 1 real solution. The graph is going to look like this. It's going to like bounce off the x-axis, but it's not going to go all the way through. It just like barely touches it. And so with that, let's say I had something like x squared minus 6x plus 9 equals 0. Again, Hardy just making these up kind of as we go here. still have A, B, and C. My A value would be 1. My B is -6. My C is 9. If I go algebra method, so B squared minus 4 times A times C. So I plug that. Let me get out of here. So -6 squared minus 4 times 1 times 9 is 0. If you get 0, you're going to get one real solution. So what would that solution be? I'd either use the quadratic formula to do that part, or maybe I'd forgotten the formula. And when I go ahead and graph this, notice it comes down, it just touches right there at 3, it touches the x-axis and goes back up. That's the only one answer that I get. Most of the time we're going to do algebra, so we actually have a number to go along with it. But other than that, a couple of them I made up in advance. I have a post-it note here that I came up with as I was kind of messing around a little bit last period. It takes me a little while sometimes, though, to kind of think through, because what you're going to learn with these is there's kind of a pattern to seeing kind of ahead of time what the number of solutions is going to be based on the signs. We're not quite that far yet. We'll get there, though. I wish I could say I was just a mathematical wizard and knew all this stuff off the top of my head. Sometimes I feel like that, but other times not so much. So, okay, one last situation. What happens if I plug it in and it's less than 0? What happens? Well, let's see. So what if I get a negative answer? So let's try that. So here's my A, B, and C. So we got B squared minus 4AC. All right, let's see here. So 2 squared minus 4AC. -44. No real solutions. What's this going to look like? Let's see. It never crosses the x-axis. It just kind of curves off here. So we can kind of start to visually see. Excuse me, mercy. Thank you. So if it crosses the x-axis twice, there's 2 real solutions. If it touches it once, there's 1. If it never crosses it, there's none. But the algebra can tell us the same story. My b squared minus 4ac, when it's any positive number, 1, 10, 12.2, whatever it is. If it's positive, there's going to be 2 real answers, even if I can't see the picture. If it's 0, there's 1 answer. The graph may be here, it may be over there, it doesn't matter. And if it never crosses, this is going to be negative. That's true every single time with these. And so we can actually use that information to figure out problems of different types. So for instance, find the discriminant. Based on the value of the discriminant, indicate the number of solutions. Okay, 0, 1, or 2. First thing, we have a problem right off the bat. We always have to have this equals 0 part. If we don't, our C value is going to be wrong. So my first job here is I need to get that back over here on the left side with my x's. And I got to do an opposite. You can't just throw it over there. Once I have equals 0, now I have my true A, B, and C values. And now I can plug those in. B squared minus 4AC AC so I get a positive number out, and positive numbers are always going to mean there's going to be two solutions. So whether I have this, whether I've had it made up, whether I have an equation, the idea is going to be the same. But we also can use it in applications. Now again, it won't give me the exact answer, but it will tell me some basics, like an athlete throws a shot put and the height can be modeled by this equation. Okay. Determine if it ever reaches a height of 20 feet. Okay. Notice here it says height. So my first job is to stick 20 in for H. Once I do, just like this first one, this has got to be equal 0. So I'm going to get the 20 out of there. So we have 0. And now I can plug it into my formula. So, again, same equation, b squared minus 4ac. Let's see here. Make sure signs and things go with you because that can make a major difference here. So you're like, okay, so what does that mean? What this means is, in this particular case, if there's no solution, if there's no real answer, if it never makes it back to the x-axis, no, it never reached that height. If you would have gotten 2 reals or even 1 reel, the answer is yes. So just as a side note with my notes here, if I get 1 or 2 reels, that means yes, this event occurred. If I get 0 reels, then it didn't. And that's true no matter what the problem is. Because, let me show you one other thing graphic-wise with this. If I type this into my calculator, into y equals, because this would be the other way I could check. Hopefully this is going to show up on my screen. Okay. Did I type that in right? No. Oh, Hardy, you got to type it in with the equals over there. I'm sitting there going, that shouldn't have happened. See, even I can have issues at times with that. Okay, let's try this one more time. There we go. So what this would tell me is, if this would have opened up and crossed here, that would have told me how long it would have taken before it reached that height of 20 feet. Like you notice when I had the 6 there before, if that would have been my actual equation, I could have said, hey, it's going to take, 3 seconds or whatever for that to reach that height. But it never crossed it. So the answer is 0. And we'll see more of these over the coming days to kind of see how this is going to work. So, as we continue to say in here, or at least I do, practice will not make things perfect, but man, it's going to make things a whole lot better. So I'm going to move my notes to the side here for a moment. Move myself in the packet, which hopefully has got some stuff done on 1 and 2 here. Over to day 3. Just going to make a note for myself, have my discriminant on here so I know where I'm heading with this. And so again, we're just looking for how many solutions once we have an answer. But make sure that your equation equals 0. Because if it doesn't, you've got to fix that first. But if it does, then you're already ready with A and B and C to plug into this. So again, take your signs with B squared minus 4AC. Simple as that. Let the calculator do the hard work. If I get a positive answer, it just means there's going to be two real solutions. Again, the quadratic formula would tell us what those solutions are. All we care about now is how many. Because again, if your answer is positive, it's going to be two reals. If it's negative, it's going to be 0 reals. And if it's 1, excuse me, if it's 1, Hardy. If it's 0, it's 1 real. Plug it into a formula, see what sign your answer has. That's all you're doing with regular discriminant work when you're trying to play with these. If, yeah.
On the right side, on the top.
Oh, all I'm saying is, if you get a negative,
No, not that one.
this one,
Yeah.
if your answer is 0, it means you're going to have one real solution. Just like we had here. When I did my B squared minus 4AC, I got 0. It meant there was one answer and one answer only, is all that's trying to say. So if I have an equation, the equation's our best way to go. If I have a graph, I'm just going through and I'm looking only at the x-axis. Because that's the place where I'm looking to see, does my graph cross that at any place? That's going to tell me how many solutions there are. If it crosses 0, it's 0. If it crosses 1, it's 1. If it crosses 2, it's 2. Literally what you see is what you get. So again, nothing real complex, especially if you give yourself a little bit of time to kind of see how this works. Now, I'm going to do part of number 10 with you. And then I'm going to kind of let you flow freely here. So Gerald's shooting a free throw. The ball is 6 feet from the floor and has an initial velocity of 20 feet per second. You're like, okay, what does that mean? 6 feet from the floor, that's my C. This velocity, the speed at which it's being thrown towards the hoop or shot, is this value in front here, this 20. Now, the hoop is 10 feet in the air. That is my H. Everything else is given to me. However, just like we saw on the other problems, this has got to be equal 0. So, I'm going to minus 10 from both sides here, because I need 0 equals. It does not affect our t squared. It does not affect our t. 6 minus 10 is negative 4. Once that's 0, and anytime that h is there, somewhere in your problem they're going to tell you what the height is. There's my A, there's my B, there's my C. So all we have to do, okay, and you're like, Hardy, you're going to tell us one of those infamous things of yours. You did something goofy, didn't you? Well, not exactly, but kind of. If, because see, this is where I needed to read ahead. So if I'd have read ahead, I'd have noticed that determine if your shot ever reached the height of 13 or 12, they're changing the H on me, and I didn't pay attention to that. That wasn't very smart of me. So you're like, so what's that going to mean for us? Okay, so here's what that means for us. When I do this, my H is going to change. So I'm going to go back to this initial problem. That's the part that's going to change each time. So I don't care. I don't care about how high the hoop is. I didn't read thoroughly. That's on me. So now I'm going to go to their expression, and I'm going to see if my shot ever made it up to 13 feet. So let me get that out of there. So this is 0. Always has to be at the start. So I get that set. And so now I can go in, because I've set it up correctly for this particular problem, and do my b squared minus 4ac. Make sure your signs go with.
So, like, say, like, you didn't read it, what if, like, you solved that, the front one, but then would it be off?
So my question, thank you. My question would end up being, well,
you did the bottom one too.
oh, so like I did that, and then I went and I tried to stick the 13 in there?
No, like, you did that one, then you read ahead, and then you did it again.
I just made more work for myself. Is basically all it is. Like this, I never should have played this game, because if I would have read ahead and seen, oh, I'm seeing how high my shot went, not how high the hoop is. Now, might you run into some problems that that's all the info you're given, and then that would be 10? Yeah, it could. But in this case, and again, if you get a negative, which means there's no real solutions, it means no, that ball never is going to reach a height of 13 feet. Or I could even, if I wasn't sure I'd done it right, because I'm a little uncertain because of my little boo-boo that I had up above here, I can always punch it in on y equals on my calculator and see, does it ever cross the x-axis? If the answer is no, it never reached it. And it may seem kind of silly. I'm like, I'm really doing 12 Hardy? Trust me, it could change things. Just that little bit of value. So do try out both. But just make sure you're using the info they've got there for your H. And then there's a little factoring practice at the bottom. And I will go back to saying what I have before. Let's say you don't have your Unit 11 notes anymore. You don't even have the blank one in your folder. It's like gone somewhere, done something. All is not lost. Well, all doesn't have to be lost. If I'm going along here on the stream, and I'm going, okay, I don't have that stuff, Hardy. Oh, wait. You've got it sitting here. It's okay to press open the netbook, not to YouTube, not to be looking at some other goofy thing, but to actually get in here and go, oh, wait a minute, look. This problem looks just like number 1 down below. Maybe I can kind of try to work my way through this. I'll ask Hardy if I'm not sure, but I'm not going to ask him right away. I'm going to kind of dig a little bit with the tools that I've got. That's what I'm talking about. Which video? Yeah, I'm going to post this up.